Hello, everyone. I'm super happy to be here talking about AI. This is a full day about AI. And my name is Bruno Capuano. I always forget about this. I'm part of the Cloud Advocate team. I focus on .NET and AI. And today I want to talk about local models, how we can start using local models and how we can move later to the cloud and how we can evolve the things that we can do local in the cloud. This is going to be a fun one. So this is very quickly the overview of what we want to do. I'm going to spend a lot of time coding, you know me, but I want to set up the context first to talk a little about small language model, Phi-3, and more. So small language model, well, this is probably new because we always talk about large language model, but the best way to introduce small language models is to think about these very amazing big models like GPT-4, but in a lower scale, in a scale small enough that you can run it in your own computer. You can run it in your own PC, your Mac, your laptop. You can even run this in a Raspberry Pi in a very small device. And there are so many advantages of using these models. The first one is that, of course, they are not as powerful as a GPT-4o model, but they are very good. Think about that. The best Phi-3 model is probably as good as a GPT 3.5 or so. So there are a couple of things that we want to think here because they are very good. And of course, the one that I'm going to use most of the demos today is going to be Phi-3. Phi-3 is one model that we released at Microsoft. The Microsoft research team did this. There are different versions, different flavors here. We have the mini with 3.8 billion parameters that we can use. We have one that also do vision, which is amazing. And then we have kind of a mini, medium, and the big one that we can use. And there are also versions available to use in Azure AI Studio, in Hugging Face, locally with Ollama. You have the ONNX runtime. Hey, we are going to see this. And the whole idea today is show how we can start here, how we can start to use this, and later maybe move to the cloud. This is what we want to do. So switch back to the code very fast. First of all, the first thing that I want to do, I talk about Phi-3, and we have a repo, an amazing repo. If you search for this is the Phi-3 cookbook. This is a great place with tons of samples of how you can use Phi-3, how you can fine-tune Phi-3, how you can use it locally, on the cloud, and more. And hey, if you even go here, you have a C#.NET lab sections that is going to guide you step by step of how you can download the model, because remember, this is local models, so you can do something as popular as, hey, I want to do a Git clone of a model from Hugging Face, and it's going to download the model. By the way, this is the one that I'm using today for doing this. And then you have some step-by-step scenarios of how you can use this with Semantic Kernel, locally, in code spaces, and more. So this is one of the most important parts. Go into Hugging Face, in example, and download the model. Again, you can use the Phi-3 cookbook at the entry point of everything that we are going to see today. And how you can use this? How you can start to use this? Okay, one of the versions that we have in Phi-3 to use it is an export of ONNX. If we go back here and see the version that we have, we can see that, hey, for the mini 4K, there are kind of different versions, but the ONNX is the one that we want. And why ONNX? ONNX is a standard. About this is kind of a nice standard, and we have libraries in Windows and in .NET and in other platforms to basically access a model. Any model that is supported at ONNX, we know how we can interact with the model. So here we have a C# project that is going to, using a path of a model, we have here the path, we are going to create and use the library Microsoft ML ONNX runtime Gen AI, and we are going to load the model. We are going to create a tokenizer to basically manage the information that we want to use with the model. And then in an eternal loop, what we are going to do is we are going to build, and this is important here, we are going to build the specific string that the model requires to understand the system prompt, understand the question, and give us an answer, and we are going to generate the parameters and send this to the model. So this is kind of this is probably 70 lines of code, part of the demo that we have here, and it works fine. If we run it here, let's do a .NET run. What this program is doing right now, as I said, is loading the model in memory, and we have a loop where we can say, hey, my name is Bruno, and now the Phi-3s are going to start to answer, hey, hello, Bruno, how can I help you today? What is my name? I can ask the name, but because we didn't implement some kind of chat history or memory here, the model doesn't know what can I do. The model doesn't know who I am. But what I really like about this is that if you are a fan of Semantic Kernel, and if you know me, you know that I am, we have the chance to do this with Semantic Kernel. So what we can do here is, I created here an example where this is an extension of Semantic Kernel that allows us to use Semantic Kernel as the main connector for the models, but interact with the ONNX model. Again, this is all part of the Phi-3. And what we are going to do here is we are going to go back to bases. We are going to have the location of the model, the Phi-3 models, like wherever you want to do it. Then we are going to create a kernel, add this ONNX runtime chat completion service, and then build the model. And after that, we just create a chat, we create a history, and in a loop, we start to ask questions to the model. This is literally the same as the previous one, but using Semantic Kernel. So we will go back here. And let me remember the name of this one. This is Lab3 Semantic Kernel 2, and we do .NET run. What we are going to see, a lot of information. This is Semantic Kernel in the back, loading the model. Takes some time, depending on how big is your machine. And then I have here in the bottom, hi, Phi-3, hello, how can I help you today? My name is Bruno. Can you help me? And here we can see, hey, of course, Bruno, I'm here to assist you. What do you need help with? And I can say, what is my name? Because by default, the chat completion service can handle history. Hey, your name is Bruno, and yada, yada, yada. So it's kind of nice how literally with a little extra lines of code using Semantic Kernel syntax, we are here in 60 lines, but this is an amazing sample. And hey, this is all running locally. Remember, this is important. And what we can do with this, if we run local, if we start to do some kind of more complex scenarios, think about we want to do kind of have information in the memory. I want to start to have some store information in a vector database in the memory and use local models to query the memory and do these kind of things. There are several parts we can do here, but we can run everything locally. And the whole idea of this RAG scenario is that I have a question here. And the question is, what is Bruno? Sorry about that. What is Bruno favorite the best amazing superhero for me? The model won't know this. And I am going to ask this. And I am using here Spectre console output to make it a little beautiful. But once I have the response for the model, which is usually, hey, I don't know, Bruno, I can't answer this question, give me more. What we are going to do, we are going to create a memory. This is going to be a volatile memory here. We are going to create a local embedding service to basically generate these embeddings. And then we are going to ask the same question, but using this prompt. Hey, answer the question that we have here. So what is the superhero that I like more? Using the memory context. And with this, we are going to have the response. And remember, again, this is all going to run using the local model path that we have here. So let's go to the terminal again. Like make this a little bigger. And let's load the one for RAG. There it is, clear, and .NET. And I'm using this here because I added some formatting, as you can see here, so it's nice to have this. So first question, who likes Batman? Oh, who likes Batman? This is part of the response that we have here. I didn't change the question. So the first question that we want to answer is who likes Batman? And the Phi-3 memory response is going to say, hey, Batman is a super popular character, appears in a lot of places, yada, yada, yada. So we are not going to have an answer. But if we take a look at the code here, if we take a look at the code that we have here, when we load the memory database, what we have here is a set of items, and these items are, okay, Gisela has the best superhero for Gisela is Batman. The last superhero movie that Gisela watched was Guardian of the Galaxy. By the way, Gisela is the friend who helped me to build this a long time ago. Then Bruno, best superhero is Invincible. The last superhero movie was Deadpool. And then I didn't like Eternals. So when I asked the question about, hey, who likes Batman? I have a very, very big response about the model that Batman is a character, yada, yada, yada. But when I ask the question again, when I ask the question using the memory, it's going to say, hey, based on the memory content provided, Gisela's favorite superhero is Batman. Therefore, Gisela likes Batman. And if we go to the facts here, yes, we have here that Gisela's favorite superhero is Batman. And we can change the questions here. We can do more. If I do the question, and because we are using this RAG locally, if I use the question instead of in English, if I do the question in Spanish, which is, what is the favorite superhero from Bruno, but in Spanish, this is ¿cuál es el superhéroe favorito de Bruno? So if we run this again, what we are going to have is that first, the response in Spanish, como asistente virtual, I don't have information about this individual. And if I ask the question again, it's going to say, hey, Bruno, favorite superhero is Invincible, which is kind of nice. This is what we have. And by the way, you can test this in other languages like French, English, Spanish. Hey, there are so many things that you can do. And remember, this is all working locally. We have a local model here, which is giving us the chance to create these embeddings and do more. But when we started to do this, when we started to aim for this scenario, one of the ideas is, okay, and how can I use this? How can I use a WinForm, in example here, that use a local model and do more? So what I did in order to see this, I searched for a chat WinForm application. And I went to GitHub and I started to see, okay, give me some samples about chats in WinForms. And I like the third one here, the A Green Tejada. I clone this one, I fork the repo, I clone it and start to work and make a lot of modifications here. But I get to a point that I build this. So let's take a look at how we can do this here. So let's close this one. And what I built in order to show this is kind of a nice one. So let's go here, focus on AI, close and close. And what we have here is a chat WinForm application. You can see here, this is the desktop application. Then we have an API that is going to manage the chat, that is going to manage the calls to the models and more. And it's all going to be wrapped with Aspire. Why Aspire? Hey, because Aspire is cool. And it's also give us a lot of information in order to see how we can use this. We can trace this. We can see how it's working. So here, initially, this is the server. Let me add some code here in the server. So let's maximize this. I have some snippets here. I use this, and I do this usually a mix between Visual Studio and Visual Studio Code. And what I want to do here is basically when I am builder, this is the program, the API. So I have the controllers, the endpoints, the Swagger stuff. I add configuration. I create a chat history here. And then let's do a local model here. So what it's going to do now, it's going to load the model as we've seen before, and it's going to answer the question. And it's going to add this into the builder services, and then I can use it. And the way that I use it here is in the chat controller, which is going to get the question. This is a class with the question, a name, a couple of information. It's going to ask the question to the chat completion service, and it's going to give the question response later. So it's a very simple API. So let's run this using Aspire, and let's take a look how it works. And I have here somewhere, this is the window, the WinForm application. As you can see, a very simple one. And I can say, hey, my name is Bruno. So if we go to see the task here, we are in the server, we have a debug in the breakpoint here, and what is going to happen, that is going to ask the question to the chat completion service, which is basically answering, let's remove this, which is basically answering the question here. So, hey, my name is Bruno, and we are going to say here, continue, and we're going to have the answer. If we go to the traces here, we are going to see how it's calling the backend. And we have this, and the final one has the response. This is because Paul is making the retries for this. But remember that we talk about, hey, Bruno, I'm feature-friendly AI. What's in your mind today? But remember that we talk about, hey, there are so many different models here. I have the chance to use Phi-3 small, medium, the Vision one. And hey, you can download this, you can clone this locally, but there are other options that are very good in order to use and test this model. So ONNX is amazing. ONNX is literally kind of the direct access when you have your models in the disk. You can use ONNX to load the model. But then we have other options and third-party applications like Ollama, which are very great because Ollama, in example, you can download Ollama to run in Windows, in Mac, or in Linux, and then you can say, hey, Ollama, download the model. And we have Llama models here. We can have the Phi-3 models here and more. If we go to the Phi-3 models, we have this version of the models, the big one, the 14 billion parameters, the 3.8 billion parameters, and more. And you can download this and have it locally. And there is also an option here in Ollama where you can run Ollama as a Docker. In Docker, in a container. Where is my Docker? Somewhere here. Oh, there it is. And when you have Ollama here working in a Docker container, hey, you can do amazing things. So let's start here. And because this is up and running already, let me open a terminal and let me show you the models that we have here. So if I run Ollama list, it's going to show me here that, okay, I have Phi-3, the big one, 14 billion parameters. Phi-3 by default, this is a small one, the mini. Then I have Llama. And how do I run this? How do I use this if I want to use this in my code? Because we are using semantic kernel and we are using kind of the basic view of what we have when we load the model, instead of doing this, what we are going to do is we are going to call this code. And what we are going to create a chat completion service, and we are going to create a new OpenAI chat completion service where we are going to say the name of the model, the URL, and then we need the API here because it's a default parameter. I'm sorry, it's not an optional parameter, but we need to add this. But with this, we are going to have a chat completion service that is going to help us to have this. So no changes in the code, just creating a new chat completion service. And now we can go back to our project here. Let's close all of the windows. And let's run this. And when we run this, we are going to start to see how we have the calls to Ollama. So let's run this. Okay, we have here the form. And if we go here to the logs of Ollama, we can see the logs here. And if we go back to the form, where is my form? There is my form. And I ask a question and I can say, hey, my name is Bruno. Can you solve math problems? We start to see in the back how it's loading the model. It's going to take a couple of seconds the first time because it's kind of warming up the model. We can see very, very small here that the model took 2 seconds to be loaded here. And the model name is somewhere here in the top. Where is the model name? Somewhere here we have the name of the model, where it say Phi-3, that this is the one that we are loading. And if we go back here, say, okay, here's Bruno, absolutely, I thrive on numbers like a starfish does in the sea, yada, yada, yada. So if I do, so I don't know, 2 plus 2, again, we are going to see a new call here in chat completions. The third one here, and it's going to say, hey, yes, 2 plus 2 is 4. And right now, what we are using is a model that is hosted in Docker with a container that we have from Ollama. If we go to the traces here and we start to see here the calls, we can see here basically the WinForm that calls the chat, that calls internally the Docker container that is running in localhost 11434. And hey, if I want to change my model from Phi-3 to, can't remember the name of the other ones. Let's go back here to the console. If I do Ollama list and I copy the Llama model, what we can do now is instead of running the model Phi-3, let's run the Llama 3.18b. Let's say the name also here. This is Llama 3.1. And then we are going to run this literally. And again, the first time it's going to take some time because it needs to warm up and connect to the model. But if I go here to the logs and I say, hey, we are going to see, yes, it's loading the model. There it is, the name. Oh, there it is, the name of the model. This time I find it, MetaLlama 3.18b instruct, and we have the answer here. So this is a super easy way to change model. And this is also a great way to basically run Ollama, to test your model here and there. And if we go to the traces here, we are going to start to see again that we have calls from the front end to the back end and to the Docker container with the calls. And there are so many things that we can do here. Remember, this is just a model that we use for this. If we want to do RAG, if we want to do more, we can literally switch and start to do amazing things. But how about going an extra level here? And the extra level is, hey, I already changed my model to, instead of load the model from a local file, calling a URL. In this case, the URL is a local port from a Docker container. But how about going to the cloud? What happens if I want to run a model, a Phi-3 model, an example that I had hosted in Azure AI Studio that I created there? So, hey, literally, with a simple change in the line, we can do this. So let me show you here. This is Azure AI Studio. There are a lot of models here. We have Mistral models, Llama models, Phi-3 models, GPT models, and more. And here in the deployments, what I have is a couple of models. I have a Phi-3. Let me open this a little. I have a Phi-3 mini model, and then I have a Vision model here. So what I am going to do, I am going to change the code to basically use this model. So let's go here. Instead of localhost, let's put that URL. Let's copy also the API key. Now we need the API key. And let's change the name of the model, which is this one. So now we are going to call, this is a Phi-3 model from Azure. I'm just changing the name. But just to recap here, what we are going to do now is call a model that is hosted on the cloud. And if you want to see how you create a model here, it's just going to the deployment, right-click, new model, select the model, choose the way that you want to use it, and that's it. So let's run this, and let's see if it works. So we have here the model, we have the chat, and say, hey, my name is Bruno. And hey, Bruno, we come here, we have a web from LIMS, I don't know. It's always answer a couple of silly things. But if you go to the traces here and take a look at the trace, hey, this is kind of nice. Start on a WinForm, call the backend, call the cloud. We have the same model up and running here. And what is important here, what is really, really nice is that we also have a vision model. Remember that at the beginning when we talk about Phi-3 and when we were here, I show you that we have a vision model. I can deploy a new model and can deploy, let's search for Phi, and we are going to find that we have find vision. This is a specific one that can analyze images and more. This is a lot of information here. By the way, you can fine-tune the model. This is amazing. We don't have time to take a look at this, but fine-tuning models, it's great. But I already have the vision deployed. I already have the vision deployed here in the cloud. So what we can do, I already changed my applications to support this. So let's make the app use the vision model, and also let's make the app analyze a couple of images. So I'm going to change the endpoint. I'm going to get the key. And I need to change the name. The name of the model is Phi-3 Vision 128K Instruct 2. So I have this. And the main difference here that I have is that when I am working in my chat controller, when I send my message, I need to double check if I have an image. So what we are going to do here is, if the question has an image, create a collection with the text and the image and send this to the model. That's the only difference that we have right now. So with this up and running, let's give it a try. And let's change the name to Phi-3 Vision. I like Phi-3 Vision. Okay, so we have here, let's select one image. I have a couple of images. I have this image of my cat. Please describe this image. And this is the image that we have here, which is my cat and a dog in the bag. And hey, it doesn't understand the image. Oh my God, this is what we didn't want to do. Let me create the model just in case I put some of the... Can you read? Let's give it a try. Can you read the text? Let me update this just in case and run it again. Asking to, I have a couple of licenses here with JD stuff. So read the text in the image. So let's give it a try to see if we can use this. So you can see here that we have JD I am, and it's not reading the text. Something happened with the model. Probably is going to be used for another third party, another demo somewhere else. But if we go to the traces, and this is what I want to show, hey, we have here again a call from the WinForm to the backend to the Vision service, and we can see here that, hey, this is the Vision service that we are using, and this is how it's working right now. By the way, we can even do this locally. We have here, I have here in the semantic kernel, I have a sample that is using the Vision model to analyze an image. And hey, it takes some time, but it also works. So if I debug here and start, this is the image that we want to analyze. Working there. And if I go here, this is the image, which is my cat and my dog. And after literally 1 or 2 minutes, I am not running GPU, I'm working on CPU. This is that we are going to have a description of the image. So quick recap of what we see while this is working. We see how we can start working with local models. We see how we can start working with the local model that you have on your disk. Phi-3 is one of the most popular examples. Llama 3.1 is super popular. We move to use this model for a Docker container. And literally changes in the chat completion definition uses semantic kernel. 2 lines, 3 lines of code, and that's it. And then we move the same lines for going to the cloud. We deploy a model to the cloud, and when we have the model in the cloud, we have the chance to literally, without changing the code, have all of those capabilities. And we can do RAG, we can do search, we can do a lot of things. And if we are using the Phi-3 models, we can even fine-tune the models to be used there. So this is an amazing chance to basically use these kind of things. So this is still working, as I say. It's going to take a couple of minutes. I am going to close the demo here. Invite everyone. Please enjoy the rest of the conference. It's been a pleasure. Promise to have a better video with the cats recognizes there. And thank you very much. It's been a pleasure. See you next one. Goodbye.